In this example, it is now your turn to use the rules of exponents and your understanding of rational exponents to simplify two expressions. Please pause the video, try these two examples on your own first, then return to the video to check your work. In part A, we have the quantity 16 s to the 8th t to the negative 4th, all raised to the 1/2 power. The first step in simplifying this is to apply that outer exponent to each factor inside the parentheses. So we will end up with 16 to the 1/2, the quantity s to the 8th to the 1/2, and the quantity t to the negative 4th to the 1/2. Once we have applied that outer exponent to every factor inside the parentheses, the 16, the s to the 8th, and the t to the negative 4th, we'll then simplify each one of those factors on their own. 16 to the 1/2 is the same thing as the square root of 16. To simplify s to the 8th to the 1/2, we will use the rule that says exponents in parentheses raised to exponents outside parentheses will be multiplied. So we'll end up with s to the 8 times 1/2. And t to the negative 4th raised to the 1/2 would be the same rule. So we would have t to the negative 4 times 1/2. Taking this a step further, the square root of 16 is 4. 8 times 1/2 is 4, so we get s to the 4th power. And negative 4 times 1/2 is negative 2, so we have t to the negative 2 power. In the directions, it does not specify whether we can finish with or without negative exponents, and as such I will err on the side of caution and rewrite that t to the negative 2 without a negative exponent. Remembering that a negative exponent means this factor belongs on the other side of the fraction, and that negative 2 only applies to the t, only the t squared will move to the denominator. So this will leave us with 4s to the 4th in the numerator and a t squared in the denominator. In part B, we have z to the 1/4 over z to the 1/5. The first step will be using the division rule that tells us when dividing the same base, we can subtract the exponents. So this becomes z to the 1/4 minus 1/5. To subtract those two fractions, we need a common denominator. The common denominator for 1/4 and 1/5 would be 20. So I would end up multiplying the 1/4 fraction by 5 over 5. And I would end up multiplying the 1/5 fraction by 4 over 4. So this would become z to the 5/20 minus 4/20. Carrying out that subtraction, 5 over 20 minus 4 over 20 leaves me with 1 over 20. And following the directions that state write all answers with rational exponents, not radicals, tells me I should stop right there. I would not rewrite this as the 20th root of z.